Okay, so this is the video going over the Chapter 4 free response review problems. Again, I've posted the 12-page rubric, which of course is ridiculously long. So I'm just going to walk you through what is important in here and kind of how I thought about it. Okay, so the first thing that's going to be important with all the problems on this test is to carefully read everything, underline words, figure out what is what. There is hardly any numbers in this unit, right? It's all words. So careful reading of the words is really, really important. So I looked through here and I found, okay, so this is how big our population is. I'm understanding that there's elementary kids, middle kids, and high school kids. And what we were hoping to do is estimate the proportion of students who are satisfied with the food. Okay, so for part A, they're asking about an SRS, simple random sample, and they told us they want that SRS to be 200 students. Okay, so part A, you were supposed to describe how to do that. Now I'm going to scroll past their example answer and point out that they say for it to be essentially correct, full credit, you need to describe a sampling procedure and it needs to include sufficient detail. So what does that sufficient detail mean? I'm going to scroll up to their answer at the top of that same page on page 2. So remember, there's label, there's randomize, and there's select. You need to mention all 3 of those steps, and it wouldn't hurt to label it 1, 2, 3 or with 3 bullets or something. Okay, so they said they could number an alphabetical list of students from 1 to 2,500, so that's the label step. Now, notice that they didn't say 0001 to 2,500. If you were to use a random number table, you would need to do that. You need a consistent number of digits. So the way we've been doing it in class, you'd say 0001 to 2,500. Here they said, though, that they would use a random number generator from a calculator or a computer. And calculators and computers don't need that consistent number of digits. It can figure that out. So that's why they're saying 1 to 2,500. But again, because on the real AP test, I don't know if they're going to have you use a random number table. I kind of want to teach you the method that always works no matter what your tool is. Okay, so we're going to get 200 unique, so ignore repeats, random integers between 1 and 2,500. Or you could have said between 0001 and 2,500. And you would get those unique random integers from a random number table rather than generator. So that's the randomize section. And then the select. So the students corresponding to those 200 numbers would be selected, would be asked to participate in the survey. Okay, so those are the 3 steps that they need as they're describing an SRS. Okay, now I am at the very end of page 2, starting page 3, looking at part B. They wanted to know what would be a reasonable variable to stratify by. If they were to do a stratified sample, what would be the variable that they would use to separate out the different strata? So I always start with what's essentially correct before I look at their example answer. They want a reasonable stratification variable, so it couldn't just be anything. It needed to be something reasonably connected to the problem, and provide a reasonable justification in context. They want context. So their example, if I scroll back up to page 2, they said one possible stratification variable might be the school level of the student, elementary, middle, and high school. That's likely what you guys thought too. They kind of gave you that information for a reason to kind of lead you there as an easy answer. So their perception of good nutrition and food may differ depending on the students' ages and therefore on school levels. There's a difference between what elementary school kids like and what high school kids like. So that is justifying that you'll get different answers depending on the level, and they used context. I see the words elementary, middle, and high school. I see food preference, that kind of thing. All right, on to part C. Okay, so now I'm on page 3, and I'm looking at what is essentially correct for part C. So for part C, they wanted to know a statistical advantage of doing the stratified sample. Like, why would this turn out better by taking the time to stratify instead of just doing a simple random sample? So for essentially correct, they wanted a reasonable statistical advantage that is not also true of random sampling. So they need to see not only why is it good, but why is it better than random sampling? And they need context and they need it clearly communicated. Okay, so their example, where are we? We're all the way up here now, back on page 2. Their point is elementary, middle, and high school create groups, they say, that differ with respect to what they value and therefore are more homogeneous with respect to opinion on this issue. You know, little kids are more likely to like bread and cheese things, and older kids might be more interested in something a little bit more interesting, like something spicy or sushi or something that's a little bit not as little kid friendly. So by then for the same overall sample size, this is what I get for not reading ahead of time. Then for the same overall sample size, a more accurate estimate of the overall proportion of students who are satisfied with the food may result. So basically they're saying if you make sure that you get, because kids might have different food preferences depending on their age, if you make sure you get a good representation of all the ages, you will make sure to kind of have all the opinions there inside your sample. Here we are. That's my favorite one. That guarantees that each of the ages will have some representation, because it is possible that a simple random sample would miss one or more completely. Like it's possible that your simple random sample could get only high schoolers, and that's your whole sample. That is possible. It's unlikely, but possible. Stratification makes sure that you're kind of getting an equally spread out sample. Okay, so let's go look at what they said. We said that. It's also worth saying, it says down here on the note, responses to part C, such as stratified random sampling, allows for inferences to be drawn for the 3 grade levels separately about the feelings of the students in those grade levels, is not correct, because that is not saying why it's better than an SRS, why it's not better than a simple random sample. A simple random sample should kind of get all of those as well. In the end, you're not going to actually get different data for the high school, middle school, and elementary school levels. You're just like, you're making sure they're all represented in there, but it's still all going to get dumped together into kind of one average in the end, one estimated proportion of people that are satisfied. So it's not like it's kind of getting it mixed up with a block design. In a block design experiment, you are getting information on the different blocks. In the strata, they're there to make sure you have a representative sample, but it is all dumped together in the end. If what they're looking for is a final estimate, 60% of students are satisfied with the food, that's not telling you about each individual age. Okay. Okay, moving on to question 2. I'm now on page 7 of the rubric. And I'm just going to write the answers in their questions here. I think that'll be easier to find. So sampling method 1 is the cluster sample. And each store is a cluster, because they're getting 8 random stores, 8 random clusters, and they're going to ask everyone at those stores. So sampling method 1, and the cluster is, clusters, and the clusters are the stores. That leaves sampling method number 2 is a stratified, and stratified is US versus Europe. Maybe you would say location in the world, if you want to sum that up in one phrase. Okay, now I'm on page 8, and I am definitely realizing at this point, by the way, that for some reason this rubric is printing the solutions twice to everything, which is why it's 12 pages instead of 6 pages. Sorry about that. I don't know why it did that. Okay, so for part B, they wanted an advantage, statistical advantage, and statistical disadvantage of cluster sampling, basically. So an advantage is that they said it's being located in only 8 stores. More specifically, it's easier to accomplish all you have to do is go to 8 stores and ask everybody. You don't have to go around to a ton of different stores. Take less time and less money. Statistical disadvantage is that you run the risk of the 8 stores not being representative of all employees. And the fact that responses with stores may not be independent. We'll talk about that more later on in the year. So those are good examples of advantages and disadvantages. Okay, and then part C, I'm now on page 9. So they wanted to know basically why it's a little bit of a repeat from question 1. Why is stratification better than SRS in this situation? So to get it fully correct, you see that sampling method 2, so stratification, results in proportions equal to those in the population. And that also results in decreased sampling variability, which means, or assures representation from both regions. Decreased sampling variability means that of all the possible samples you can get, all of them should include some US and some Europe. Whereas an SRS, so the second part of your explanation, you needed to say why an SRS won't do these things. Related simple random sample might result in proportions from the 2 regions that are not consistent with the population proportions. Basically, that you could get all from Europe or all from the US. So you're not guaranteeing like that European American proportion that is true in the overall population. Okay, so essentially correct, you needed to say that issue. SRS could be a really extreme sample, whereas stratification makes it so it's not as extreme, it's at least proportionate to the population as far as US versus Europe.